In Chapter 14, you will learn about two tests of relationship, correlation and regression. Correlation is the test statistic of choice if you are seeking to measure the strength of a relationship between pairs of scores on an X and a Y dataset. Regression is the test statistic of choice if you want to predict a score on the Y dataset based on the scores of the X dataset. We will discuss correlation first. Click on the worked example of a correlation link that is located next to the link to this video and examine it as I describe the characteristics of a correlative relationship. Examine the pairs of scores on the worked example. Do you notice anything about them? If you noticed that when a score on the X dataset tends to be lower, its partner score on the Y dataset tends to be lower as well, or if the X value is higher, its partner Y value is higher as well, you are correct. When we talk about the direction of a correlation relationship, we are referring to the mutually influencing relationship between the pairs of scores. A positive correlation is when, as the X values tend to increase, the Y values tend to increase as well. An example of that would be, as temperatures increase, the more cold beverages people consume. A positive correlation can also be when the X values decrease, the Y values also tend to decrease as well. An example of that would be, the less people smoke, the less lung cancer they have. To sum up, a positive correlation is when the X and Y values both tend to increase or both tend to decrease. Conversely, a negative correlation relationship is when the X values tend to increase, the Y values tend to decrease. An example of that would be, as temperatures increase, the less hot coffee people consume. The form of a correlation relationship can be linear, which means that there is a direct, mutually influencing relationship between the pairs of scores on the X and Y datasets. Another possible form is curvilinear, which describes an X-Y relationship that is not directly mutually influencing. We will be spending all of our time talking about linear relationships. Finally, the strength or consistency of the relationship is represented in the correlation test statistic. You will learn to compute in this chapter the Pearson product moment correlation coefficient, or Pearson's R. It is the test statistic you will learn and use to measure correlation relationships. The range of values that you will generate from the Pearson's R formula range in value from a negative 1.00, representing a perfect negative correlation, to a plus 1.00, representing a perfect positive correlation.